Let us keep discussing the electric field. In previous lessons, we learned that a charged body has an electric field around it, where an electric force of attraction or repulsion can be felt by other charged bodies. This field is often represented by imaginary lines of force, such that they show the direction of the field at that point. These electric lines of force show the path that a positive test charge will follow if placed in that electric field. We also learned that the force experienced by a charged body in an electric field varies with the charged body's position in this electric field. And this is a lot like the aroma of a delicious meal cooking in the kitchen. A faint scent could be perceived from even 100 meters away. But as one gets closer to the source, the strength or intensity of this aroma increases. So the closer the charged body is to the charge producing the electric field, the greater the magnitude of electric force that will be experienced. And this effect is what we refer to as electric field strength or electric field intensity, which leads us to what we shall discuss in this lesson: electric potential. So say we have a negative charge Q producing an electric field, and a small positive unit charge A being pulled in towards Q. If I now move A closer to Q in the same direction that the field was already moving the charge A in, then it is considered that I'm doing positive work, since the field and I are working together. An analogy can be found in gravitational fields. Say the Earth is attracting an object at some height and nothing is holding that object. The object begins to fall, right? Now, if I push the object further while it is falling, I'm working with gravity and it is easy. In fact, with or without my help, the work will be done. I'm doing positive work. But you know that as this object is falling, it is losing potential energy. This is because the potential energy depends on height, and a falling object is losing height as it falls. But what if I wanted to raise this object to the same height it fell from? Would this be easier or harder? Harder, of course, because I am working against gravity. But also, this work against the force field increases the potential energy of the object because the height, or in general terms, the distance from the source of the field, is increasing. Electric potential, denoted by V at a point, is defined as the work done in bringing a unit positive charge from a reference point to that point against the electrical forces of the field. The reference point is usually a point of zero potential at infinity. But in practice, the Earth is taken to be at zero potential. And this is why whenever a conducting body is connected to the Earth, it is said to be grounded or earthed. Another way to define electric potential is as the potential energy in joules per unit charge measured in coulombs in an electric field. This unit, joule per coulomb, is known as the volt. Now, what we have learned, electric potential, we were ready now to learn how this affects the movement of charges, which moves from a place of higher potential to a place of lower potential. And this is known as potential difference. Want to know more? See you in our next lessons.